Hello viewers and my dear students. Welcome to session 3 on problem 5 on analysis of beams. Here I will be giving you demo on overhanging beam with moment using Ansys Mechanical APDL to obtain bending stress and deformation diagrams. See here, I have this is session 3. In the first two sessions I concentrated only on bending moment and shear force diagrams. In this session, we'll totally concentrate on how to get bending stress and deformation diagrams. Okay. See here, the problem is same. The problem is same. But only thing is, same problem and all that, 0.2, 0.3 cross section and all that, overhanging beam, same problem. Here, the question is, draw bending stress diagram by finding finding bending stress at various loading points using theoretical procedure and hence find maximum bending stress. Use Ansys Mechanical APDL to verify the above answers and find deflection curve of the beam and maximum deformation due to loads and moment applied and all that. The same problem. You see here, you know already we have to concentrate on bending stress diagram now. First you get the bending moment diagram what we have already got. This is the bending moment diagram what we have got in other sessions, first two sessions. This same thing you take. Here in unfortunately everywhere maximum here is also 6 kilonewton meter. Here also minus 6 kilonewton meter. Here also minus 6 kilonewton meter. The bending stress diagram will be more or less same like this. Okay, as you see here, maximum bending stress m into y by I. I am here everything is 6,000 only. I can apply only 6,000. Had it been 8,000, I would have put 8,000. See 6,000 into 0.3 by 2, 0.2 into 0.3 cube by 12 means is 2 into 10 to the power of 6 Newton per meter square you get. 2 MPa you should get. And this will be the bending stress diagram. See yes, same as that. 0. Here it should be 2 MPa. Here it is minus 6, no, minus 2 MPa. Here it is 0. Here it is minus 6,000 Newton meter, no. That is why it is minus 2 MPa. Here it will be 0. Okay. In that way, for 6,000, it is also 6,000. This also 6,000. In that way, for 6,000, I have calculated. It is 2 MPa throughout. 2 MPa minus 2 MPa minus 2 MPa. In that way, I have got the bending stress diagram. This has to be verified using Ansys. Okay. Now, we will go for Ansys now. Ansys, as you know, has changed the change job name. Okay, make it ready. Gurdat, overhang beam, bending stress diagram, you say. A new log and error files. S, you say. Okay, you say. Okay. Then, file, change title also you do. Make every title, everything okay. Okay. Then, beam analysis with overhang and moment, bending stress diagram. You give some title so that you should be in a position to understand what exactly you are doing. Now, I've changed the job name. I've changed the title, everything. Once you do this, the procedure remains same. Preferences, structural you go, say OK, preprocessor, element type, add, edit, delete, add you go, beam 2 node 188 you take, save OK, just say close. Okay, material properties you go, material models you go, structural, linear, elastic, isotropic you go. As you know, it is 210 dpa, it is E9. Okay, it is 0.27 is the Poisson's ratio. It is 210 into 10 to the power of 9 Newton per meter square. That means when it is Newton per meter square, this Young's modulus holds the key. Next, the modeling should be in meter only and the loading should be in Newton only. Then only you get the exact answers. Okay, 210 E9 Newton per meter square. See that the loading is in Newton or Newton meter and modeling is in meters. Okay, say. Material exit you do. Okay. Material exit you do. Now you see here. Then you go for sections, common sections. 0.2 you take, 0.3 you take. You just say okay. Okay, 0.2 is the width, 0.3 is the depth. You take it okay. Then once you do this, you go for the modeling now. Modeling, create key points in active coordinate system. Okay, key point 1, 0, 0, 0. apply. Key point 2 is, you just see, it is, key point 2 is 200. Key point 3 is 400. Key point 4 is 600. Okay. Key point 5 is the overhanging part. It is 700. Correct, no? Then key point 1, this is 2 meters, this is 2 meters, this is 2 meters, this is 1 meter. I think it's okay. Then key point 6 you take, it is 7 minus 1 you take. Okay, this you do this. This is 2, this is 2, this is 2, this is 1, this is minus 1. You can take any distance here, any distance. It is only orientation point. Just to turn the beam by 90 degree, we want this point. Okay, now I'll demonstrate clearly. Carefully see, create lines, straight line, join 1 to 2, 2 to 3, 3 to 4, 4 to 5 you'll do. Okay, just say okay. Okay, now once you do this, then you go for meshing. See here, now I want you to tell one very important thing. Why orientation is required for this beam, I'll tell you. These things I've told you already. Anyway, it's a repetition. Now, say here, mesh attributes. Okay, picket lines. You click on this, click on this, click on this. Say okay. Okay. Oh, don't pick orientation key point, let us say. Just take the default. Just say okay. Okay. Then size controls, manual size, lines, picket lines. You take this, 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 and this. Okay. And say okay. And let us say number of element divisions is 25. Okay. Just say this. Okay, 25 here, 25 here, 25 here, 25 here. I not use this key orientation point. That means I have not rotated the beam as of now. Okay, blindly I am doing. Okay, I have done this. Then let us say I'll save this. So that let us say I'll get back this up till here. Okay, save DB. Okay, now what I'll do, I'll mesh, let us say, mesh, lines, pick all. Okay. I meshed lines, pick all I'll do. Okay. Now plot controls, style, size and shape, display element on. If you do okay, now if you do go for isometric, you see here, the beam is oriented wrong. That means this depth, this is 0.2, this is 0.3. 0.3 should be parallel to y-axis. The depth should have been more, but now it is the width. Now in this way, if you load on this, naturally you get a pseudo deflection. The deflection will be more. And also the moment of inertia also, here what you get will be less. As a result, unnecessarily the bending stress what you get will also be more. This orientation is wrong. Can you understand? See here, I am enlarging this and showing it to you. This orientation is wrong. This is 0.2, this is 0.3. But actually this should be 0.3 and this should be 0.2. That means you should always get 0.3. The depth should be parallel to y-axis. Okay, now it is parallel to this z-axis. Okay, it is in this way. Okay, that means this orientation has to be changed. That is why what you do is, I'll resume DB. I'll come back to this. Okay, plot, multi-plot. Okay, I'll come back to this. Now I'll go for, I'll orient this one. Since the orientation is wrong, no, I'll orient this. Mesh attributes, picket lines. I'll take this, I'll take this, and take this. Okay, I'll say okay. Now I'll compulsorily pick orientation key point. I'll click here because I want to turn this by 90 degree. That is why I have selected this pick orientation key point. Okay, I'll say, I'll click on this point. Remember this. Very, very important procedure. Many go wrong. They will not be knowing this procedure. If you know this, you are doing things properly. Then say okay. Okay, once you do this, okay, then you do mesh, lines, pick all you do. Okay, now you see whether the orientation now, whether it has turned by 90 degree or not, you just say. Plot controls, style, size and shape you go, display element on you do, say okay. Now you see this is proper. Now you see, if you enlarge this area and say, can you see this? This is 0.2, 0.3 should be parallel to y-axis, and you are loading on the top surface. And what you get is, since this is B, this is D, BD cube by 12, that is moment of inertia will be more, and it will be at the bottom. M into Y by I, no? It will be at the bottom, and you are getting lesser stress, comparative, correct stress you get. And since you are loading at the top, even the deformation also will be proper, and bending stress also will be proper. Everything is proper if you orient the beam. I think I have made it clear. If you don't take the orientation key point, it would have been in the other way. All wrong answers you will get. Particularly for getting bending stress, this orientation has to be done. Okay. Now, as you see here, then I'll go for plot control since the orientation is proper now. Style, size and shape, orientation, I'll make it off, and I'll go to the front view. This has been done. Okay. Now, as you see here, as usual, plot lines if you do, you know these things also. Plot lines you do. Now you go for loads. Now pre-processing stage is all over. Okay. Now we will go for solution phase. Loads, define loads, apply, structural, displacement, on key points. I take this point and this point and say okay. UX, UY, UZ, rotation X, rotation Y, you make it as 0. Okay. These things you make it 0. Okay. And as you know, here and here you have a here and force moment on key points. Here and here you have a force moment of Fy is minus 6,000 kilonewtons. Okay, sorry, 6,000 newtons. I think it's okay. 6 kilonewtons or minus 6,000 newtons. Just say okay. This and this okay. And at the same time, force moment on key points, you click on this point and say okay. And it is moment about Z. It is, since it is anti-clockwise moment, you take 12,000. X, Y, okay, X is this, Y is this, Z is perpendicular to this plane, and about that plane, it is 12,000, and I have applied there, okay. That means at this point, it is 12,000 Newton meter applied in the anti-clockwise direction. Now, I have completed this problem by doing the loading and all that. Now, we are still in the solution phase. Okay, now solution, solve, current load step you do. Once you do current load step, you are getting the solution is done, close you do. Okay. Did you follow? Now, once you do this, the answers and all that we will extract in the next session. Okay. The answers for all the, that is, we have applied the loads properly and all that. The answers and all that we'll extract in the next session. That is session 4. Now we have come to the end of session 3. Thank you very much for watching. Please look to the session 4 also to find out the finer aspects of extracting the results. Thank you.